General purpose. General purpose languages represent the foundation of modern development, acting as universal tools for solving a wide variety of tasks. Python, JavaScript, and Java are the workhorses of the industry, designed to balance developer productivity with system performance. They serve as the primary choice for everything from back-end server logic to dynamic client-side interfaces. By covering the entire spectrum of programming, these languages allow developers to build comprehensive products, from mobile applications to cloud infrastructures. Understanding this group is a fundamental requirement for any professional in the field, as they provide the necessary versatility to navigate different technical challenges. They serve as the baseline for a developer's toolkit, ensuring the ability to deliver functional and scalable solutions in any commercial IT environment. Level 2. Performance and Backend. Performance and back-end languages shift the focus toward high-speed execution and server-side robustness. C++ and PHP, while different in their application, both prioritize the stability and speed required to power high-traffic systems. C++ provides granular control over memory, essential for high-performance computing, while PHP remains a cornerstone of the web, handling complex server-side requests with ease. This level requires a deeper understanding of how code interacts with the server hardware and how it handles data requests. It is the domain of large-scale web services where efficiency is not just a preference, but a requirement. By optimizing back-end processes, these languages ensure that digital services can scale to meet the demands of millions of concurrent users. Level 3. Systems and Enterprise. Systems and enterprise languages, like C#, engineered for complex, multi-layered environments. Designed to provide a balance between deep system integration and high-level abstraction, C#, the standard for building large-scale corporate software and enterprise applications. It leverages the .NET framework to ensure that complex business logic remains modular, secure, and maintainable over years of development. This level is defined by its ability to manage massive, multi-team projects where consistency and reliability are paramount. Engineers at this stage focus on robust architectural patterns and long-term project viability, ensuring that the software can evolve without compromising the integrity of the core system. Level 4. Modern Application. Modern application languages, Ruby, Go, and Swift, are dedicated to productivity, elegance, and the reduction of complexity. These languages favor intuitive syntax, allowing developers to focus entirely on implementing features rather than fighting verbose code. Go offers incredible speed for cloud-native services. Swift provides a secure and modern standard for Apple platforms, and Ruby excels in rapid prototyping. The philosophy here is to remove the noise of older systems. These tools are designed to shorten the distance between a creative idea and a deployable system, making them the choice for those who value clean, maintainable, and highly readable code bases that can iterate at the speed of modern business. Native and Data. Native and data languages, including Rust, Scala, and R, introduce a higher tier of technical rigor. Rust brings memory, safety, and high performance to systems programming. Scala integrates functional and object-oriented paradigms for complex data processing, and R serves as the gold standard for statistical analysis. Working at this level demands a deep understanding of data structures, compiler constraints, and mathematical models. It is the domain of mission-critical systems and advanced data science, where the cost of a runtime error is prohibitively high. These languages force the developer to write robust code, prioritizing stability and efficiency above all else, making them indispensable for high-stakes environments. Level 6. Concurrent and UI. Concurrent and UI languages, like Dart, focus on the challenge of fluid user interaction and asynchronous event handling. Designed to facilitate highly responsive cross-platform interfaces, Dart allows developers to build complex UIs that remain performant even when dealing with intensive background tasks. This level is defined by the ability to manage streams of data and user events simultaneously without blocking the main thread. By optimizing the experience layer of the application, these languages enable developers to deliver smooth, high-quality visual interactions that feel native across devices. It is an essential tier for anyone building modern, user-centric mobile and web applications that require constant interaction. Level 7. Pure Functional. Pure functional languages. Languages like Haskell represent the pinnacle of declarative design. Here, the programmer moves away from the step-by-step imperative style to a mathematical approach, where programs are constructed as compositions of pure functions. This paradigm shift makes the code incredibly predictable, testable, and mathematically sound, as functions are guaranteed to produce the same output for the same input without side effects. This level fundamentally changes the developer's thought process, encouraging a focus on data flow rather than state mutation. It is an advanced tier of programming that emphasizes architectural purity, making it ideal for systems where correctness and formal verification are the highest priorities. Level 8. Declarative and Legacy. Declarative and legacy languages, Lisp, COBOL, and Prolog, represent the historical and academic core of computer science. These languages define rules, facts, and logical constraints rather than execution paths, allowing the machine to derive the outcomes. Lisp's homoiconic nature allows code to treat itself as data, whilst COBOL maintains the backbone of global banking, and Prolog drives complex logical inference systems. This level is not aimed at mass-market application development, but at the fundamental exploration of computation, artificial intelligence, and expert systems. It is the domain of architects and theorists who understand that programming is a form of formalizing logic and building systems that can reason and evolve.